Hello? Okay, hold up, hold up. What? I don't know why that was happening. Test. Why that was happening. Test. Okay, cool.
Hi
And
everyone. At the
let's also test this.
end of the last episode, I gave the task of spawning in some falling blocks. So I'm just going to go ahead
Yep,
and implement
everything's
that quickly.
working. Everything is working
By
now.
creating. Hi everyone. At the end of the last episode, I gave the task of spawning in some falling blocks. So I'm just going to go ahead.
Okay, and I have actually already done that. So let's just test this again. Where's the empty game object spawner? And actually, something I do want to do here is make this public. Make this rate of fire. Public. And oh my goodness, I forgot. Sure. Yeah, I'll do that later. Whatever. Okay, so I kind of forgot how to do some of this stuff. Camera.main.aspect. Okay. And then camera.main.orthographic size, which is the height, which is the height. Or the width. It's the width. Wait. Okay, so it's the height. I'm pretty sure it's the height. Got it. Okay. And then I did put notes here. Okay, and then this is just calling the position of the empty game object. Gosh, how did I do this all on my own? I'm like amazed at the things that I've been able to do because this is kind of complex, but I'm gonna do it again. So it's gonna be cool. Okay, so if fire time greater than or equal to rate of fire. Got it. Yeah, that's what I want. Public. So I do want to make that public here. So, in the video, it kind of looks like.
Ahead and implement that quickly. Hi everyone. At the end of the last episode, I gave the task of spawning in some falling blocks.
I don't know if that.
So
What is that?
at the end of the last episode, I gave the task of spawning in some falling blocks.
Is that a tenth of a second or a fourth of a second? I can't tell. Oh, okay. That's way too many. So no, let's try fourth. Okay, maybe it's half. Maybe it's a half a second. Okay, it is a half a second. It is indeed a half of a second. And what did I put on these blocks here? Hazard controller. Oh, yeah. So I did put it at negative 1.5 times the height. There. And actually, there would be an easier way to do this. There would be a more optimized way to do this, actually. If I just create like a plane or a cube or a rectangle, and I just set the position to this here, and then I just do on collision, or what is it, on? I forgot. Wait, what is it? What the heck is it? On trigger? No. Got it. Oh. Okay. Got it. So it is on trigger enter. Uh, sorry. Sorry. So this is enter. This is 2D. I don't know if that would matter, but that would be a more computationally efficient way to do it, because then I wouldn't have to be checking it every update. So yeah, boom. Okay, let's continue.
So I'm just going to go ahead and implement that quickly. Start off by creating a new C# script. Call this falling block. And let me just create a little cube object to act as the falling block. So I'll attach the script to that and open the script up. You're going to want a variable to control the speed of the block. So just call that float speed, maybe set that to 7. And then in the update method, you can just...
What? Wait, he doesn't... What? He doesn't use physics? Really? Okay.
make this fall straight down by the speed, so transform.translate vector3.down for our direction, multiply that by the speed, and multiply by delta time. Alright, so if we press play now, this should fall straight down. So we can rename this falling block and create a prefab out of that by just dragging it into the project. So we can now delete it from the hierarchy.
You're not using
I'm just going to quickly organize the project a little with some folders. Create one for scripts and put my 2 scripts in there. Another folder for the prefabs in our project, of which we only have one currently, and a final folder for the scenes. All right. Let's then create a third C# script, call this the spawner, and I'll also make an empty object in the scene, call this something like spawn manager,
Why?
and we can just add the spawner component to that.
All right.
And if we open that
Let's
up,
keep
we'll
going.
want to get a reference to our falling block prefab. So let's say public game object falling block prefab. Then we also want to calculate the screen size in world units so that we know where we can spawn the blocks in. So let's create a vector2 screen. Once again, it's the half size that we're really interested in. So screen half size world units. And then we'll just set that in the start method. So screen half size world units is equal to a new vector2. Then we saw how to calculate the half width in the previous episode. So that was just getting access to our camera and getting its aspect ratio
I see what
and
he's
multiplying
doing.
it by the camera's orthographic size. And then since orthographic size is literally half the screen height in world units, for our y we just pass in camera.main.orthographic size. Alright, so in the update method, let's now spawn in a falling block.
Vector2?
We're first going to want to figure out where to spawn it though, so let's create a vector2 spawn position equal to a new vector2.
I did that, right? Okay, so that is correct, but that is what I just did there, the on trigger enter. But I did do that. Yeah, I didn't do half size. I didn't do half size, I just did width.
So let's say it can be anywhere along the width of the screen. So we'll use random.range between negative screen half size world units .x and positive the same value. All right. And then for the y-axis, we want to spawn it in from the top of the screen. So let's just say positive screen half size world units .y. Okay, let's now instantiate.
That's almost exactly what I did. It's almost exactly what I did. But I guess what he's doing is better. He's actually not having the block have a rigid body. He's actually not doing it with physics, which is probably better. So I'll go change that, I guess.
Instantiate. So we'll pass in our falling block prefab, pass in the spawn position. For the moment, we don't want to give it any rotation, so we can just say quaternion.identity, which just means 0 rotation. And that's done. So currently this would be spawning a new block in every frame, which we don't want. So let's create a public float up here. Let's call it the seconds between spawns. So say 1 spawn every second. And then we'll also want a float called something like next spawn time. All right, so what we can now do is we'll say that if the current time in the game is greater than the next spawn time, then we're ready to spawn in the next object. And when we spawn in the next object, we'll say that the next spawn time is equal to the current time plus the seconds between spawns. So
That doesn't work. What? Oh, okay. When time is greater than. Oh, right. Sure. I see. This counts up. It is a different way of doing it, for sure. It's definitely a different way of doing it. Okay, I'm just gonna change this to 0.5. And I'm not gonna make this public. Okay. That's no longer public.
once we pass the spawn time,
Yeah, it's a different way to do it. Definitely. But I think either way works. And this isn't really like super necessary, but whatever, I did it anyway. Okay, and he like defines the spawn position inside the if statement, which is a little weird. Okay. I mean, I guess I don't think that really matters a lot.
the
Yeah,
spawn time
I
gets
think
increased
either way
by
works.
the amount of time we want between the spawns, so that's how much time will pass until the next object is spawned. Okay, let's go into Unity, and we're going to want to, of course, apply our prefab to the slot here. So let's go into our prefabs folder, drag that in, and let's press play and see if this is working. So the blocks are falling down from what looks to be random positions, so that's very nice. One problem is that when they're spawning in, if I can just catch one, here we go. It's spawning in with its center at the top of the screen, so we can still see the whole bottom half of it. So when we spawn in the object, for its Y value, let's just add half the object size. So we know that the objects are at a scale of 1, and currently we haven't changed that. We will be changing that later, but we haven't changed that yet. So let's just say plus 0.5 for half the height of the object.
That
and if we
makes
press play
more
now,
sense.
we can see that they get spawned in from above the screen.
That is,
All right,
that's
so this
better.
brings us-
That's probably better than what I did. But mine is like just in case, I guess. Mine does a lot of things just in case.
To the next task, which
Okay.
is to give the falling blocks a random size, and also to make some of them fall in at an angle so that their paths are a little bit harder to predict. So, as always, I recommend you pause the video and try get this working on your own from above the screen.
Okay.
Alright.
So actually, I gotta change some things because that makes sense. I do it while also keeping gravity the same. I feel like I can, except for the fact that except for the fact that I would have to rotate the camera. So I could do the same effect, but I'd have to rotate the camera randomly, but also rotate this. I would have to put the player, I would have to make the player a child of the main camera. Would that even, like, matter? Would that even matter? Wait a second. Would that be... Oh, I see. Yeah, it would like kind of make things... It would look like the blocks are jumping instead of like actually actually moving separately. So yeah, basically, yeah, I can't do that. All right, have to delete this. Let's see, that did, I don't think that effed anything up. Yeah, so now I'm going to do, I mean, everything still works the same from what I know, except for the fact that these are just gonna be, these are just gonna stay up there. Okay, yeah. So they're just going to stay up there. So if I do this, if I open this, and I just do what he did, which I just create a float, speed, and then I do transform dot translate. then I do vector 2 down times speed. And I can just make this public. I think I did that correctly. Nope. Okay. But I don't have a speed. I actually don't have a speed yet. So here we go. Bang. We do that. 10. I don't know. Sure, 10, why not? Oh, it doesn't work. Ah. It's not working. Okay. I'll worry about time dot delta time later, I guess. Sure, I'll just set this to 10. And I'll make it not public anymore. Alright. I'm guessing that's too fast. Oh, and that's still way too fudging fast. Okay, so I am gonna actually worry about this right now. And now I'm just gonna set that to 5. Okay, cool. Nice. So now 10 should actually be a reasonable thing. A reasonable speed here. Because my FPS is apparently way too high. Okay, so the
this brings
next
us
thing.
to the next task, which is to give the falling blocks a random size, and also to make some of them fall in at an angle so that their paths are a little bit harder to predict. So, as always, I recommend you pause the video and try get this working on your own.
Okay, so we are not changing. So this is just the scale, just changing the scale. Fair enough. And um, just changing the scale. It's literally just the scale. Okay. Scale and rotation. So rotation. I think we do that with this. So we do. Um, let's just make a new one. Let's just do float. Okay. Float. Um, hazard scale. Okay, and then float hazard rotation. And we're going to set these to, we're going to put them here. So new quaternion. Okay. What is it? Euler? Is it here or is it... How do I do this? Vector, sorry, vector 3? Vector 2 dot Euler angles? That doesn't work, does it? Okay, I completely forgot how to do this. Is that actually it? No. No, it's not. It's actually not. Okay. Let's do scale first. Vector 3, no, transform. So this transform. I mean, we wanted to update every single time. So transform dot scale, local scale. Okay, is this equal? Euler angles. Can I search? Can I search? I don't know why I'm doing this. This is for scale. What the fudge am I doing? So this is vector 3. Why is it a vector 3? But if it's 2D, thinking this is probably alright. And I can just copy this, honestly. And just cut that out, and then cut that out. Min inclusive, max inclusive. Okay. So right now, I don't know. Sure. -1, comma 3. I actually really don't know how to do this. Okay, this is actually going to be hazard rotation or hazard scale. And then, let's just copy that. Can I not do that? Oh, this is a vector. Never mind. So vector 2, hazard scale. And this shouldn't be there. We do transform dot rotation. What? Scale, sorry. Equals hazard scale. But this can really only happen. Okay, actually, no, I'm kidding. I'm kidding. So this can actually only happen here. Oh, that is interesting. Okay, does this not let me do the scale? I'm thinking it does. So, hazard rotation equals new. Can I please? I forgot. I completely forgot how to do it. This also has to be vector 2. Okay. Actually, let me do quaternion dot Euler. I'm trying so hard.
Okay, so to Hi everyone, in this episode we're going to and we want to set this equal to the transform a quaternion value. Quaternions are a little bit tricky and we'll definitely discuss them later on in the series, but Unity does provide a much more intuitive way of working with rotations with the Euler angles variable, which you can see is just stored in our familiar vector3 format. So if we wanted to increase the Euler angles over time, we could just say transform.eulerangles plus equals, and we could create a new vector3. Say we want to rotate it on the y-axis, so we just say 0 for the x, and then for y we could say maybe give it a speed of 180 degrees per second, so we'll need to multiply that by time dot delta time, and then just 0 for the z-axis. Let's save that and give it a try. So if we press that by time. That's in a short example, forward or rotate method. So you can see this takes in Euler angles. So we can just pass in what we had before, vector3.up multiplied by time.delta time multiplied by 180. And now by default, the rotate method works in object space. So if we press play, we'll see automatically this is now rotating around its local y-axis. If we want to specify that it should work in global space, then we can just add a comma, and we can add this extra space parameter.
Okay. This is gonna be, I don't know, negative 90. 90. It's only gonna rotate one way. Wait a second. Okay. Sure. So X, this is X, this is Y. What? Z? So I'm guessing it's Z? I'm so confused. I'm so confused. I'll figure it out. I'll figure it out. This is absolutely not correct. But I'll do it anyway. Hello. Welcome. Okay, I'm tired. I'm tired. So, yeah, this is absolutely not correct. Oh. Oh. Okay. 100% not correct. Not correct. Absolutely not correct at all. Huh. Okay, I don't know how to do this, so I'm just gonna watch the tutorial.
Space dot. Hi everyone. At the end of the last episode is the maximum, so let's call this spawn. But we haven't changed that yet, so let's just say plus 0.5 for half the height of the object. And if we press play now, we can see that they get spawned in from above the screen. Alright, so this brings us to the next task, which is to give the falling.
Yeah, also, where's my spawner? Oh, this is not half of the height. This is not a... Wait. This is not half of the height. This should be like out here. Oh wait, does it change it though? No, it doesn't. Why? Why does it not do that? I have it. I have it right here. 1.5. If I make this 2, what's gonna happen? Oh, because it's only half. It's only half. It's only half. That's why. I'm dumb. I dumb. Okay, perfect. I don't know what I had this on before. Why did I have it on that? That doesn't make any sense. Okay. So, now what? Now I need to...
falling blocks a
Yeah,
random
I'll
size.
just watch this. I'll
And
just
also
watch
to
it.
make some of them fall in at an angle so that their paths are a little bit harder to predict. So, as always, I recommend you pause the video and try get this working on your own.
Okay, and he did make the player smaller, the player object smaller, I think. What is this called? Yeah, the player object smaller. And let's see.
Hack the galaxy.
Thank you.
Ah!
Hello everyone. Over the next few videos on negative object move, we'll first want to scale it up variable. Let's instead of player.
Yeah,
This of course means that if we decide to
like
hi everyone,
he just
at the
made
end of
it
the last
smaller.
episode,
Just
if we press play now,
because.
we can
And he didn't have that in the instructions. He didn't have it in the instructions. I'll never be able to forgive him. Let's see. What did he put this at? 0.25. Okay, that looks about right. Actually, not what I wanted to do. Whoops. Okay, and
you can see that they get spawned in from above the screen. Alright, so this brings us to the next task, which is to give the falling blocks a random size, and also to make some of them fall in at an angle so that their paths are a little bit harder to predict. So, as always, I recommend you pause the video and try get this working on your own. Okay, so to implement this, we're going to want to head over to the spawner class, and we'll want to specify a minimum and a maximum size that the blocks can be.
True.
So to represent a min and a max value, I usually just use a vector 2, where the x value is the minimum and the y value is the maximum. So let's call this spawn size min max, and then in the update method, just before we calculate the position, we can say float spawn size is equal to random.range between the spawn minmax.x and the spawn size minmax.y. All right.
Okay. Fair. That makes sense. That makes sense. It just needs a min and a max. I don't know what the heck I'm thinking. I don't know what I'm thinking. Thinking that there needs to be four freaking 4 values in here. Well, 2 values. Well, yeah, 2 random values. I don't know what I'm thinking. Oh, never mind. Sure, I'll just do it his way, I guess. And, actually, I don't even know what I would call this. I don't know, hazard scale actual? Hazard scale... Oh yeah, I could do, this one is range, hazard scale range. This one is just going to be hazard scale, which I like putting my variables up here. So I'm just going to do that, and then I'm just going to do that. And then I don't know what I'm doing. Do I want to even make this public? Sure, I'll make it public. Why not? Okay. I don't know why I even... Is this actually gonna work? Okay. Yeah, and then random dot range hazard scale range dot x hazard scale range dot y. Okay. And that should be fine. It's a vector 3. Why is it a vector 3?
And then, as you know, the instantiate method allows us to pass in a position as well as a rotation. but it doesn't allow us to pass in a scale. So if we want to set the scale of the newly instantiated object, we're going to need to get a reference to that object. So hopefully you recall how we do this from episode 11. We first want to see what type of object the falling block prefab is. So we've
Why do
specified
we
it over
have
here
to
as
do
being
that?
a game object, which means that we can cast the object returned by the instantiate method directly.
Why? That is so annoying. Okay, that's annoying. That's annoying. I'm so tired today. But sure. And I already did this. What? And I already have it. It already exists. I don't know what. Scale. There's a scale, bro. What?
Directly to a game object. So we can say game object, let's call this new block, is equal to, and then we cast by enclosing the type game object inside of parentheses. Alright, so we can now say new block dot transform dot scale.
Okay, sure. I'm getting it. I'm getting it slowly. I need to do this more often, just so I actually. Why? I don't really understand why you have to do this. Because it's already a game object. You know, you typecast here. I don't know why you would have to do this. Why you'd have to do that. But I don't know. I'm dumb, I guess. Okay, let's see. What is it? Float to Unity Engine vector 3.
Scale is equal to vector2 dot 1 multiplied by the spawn size. So it will have a scale of spawn size.
That's what I thought. What is happening?
On both the x and the y axes. Let's save that.
I'm a little confused why you need both, but alright.
And go into the spawn manager object, and we want to just set a min and a max value. So I'll say maybe somewhere between 0.3 and maybe 2.3. Let's play that. So we've got these objects falling.
I get it. You can't make it negative. You can't make it negative. I don't know what I'm doing. I have to save this first. Sure. 0.3. You know what? Let's go crazy. 0.2. Whoa! And 3. I really don't want to do a whoa. That's weird. Did I F this? Yes. Let me just make that normal again. And let me just remove that completely. And that should be good. Perfect. Perfect. Absolutely beautiful. Those are way too large. Those are way too large. Okay, now let's see what would happen if I did this. Completely understandable. Completely understandable. Hazard scale. So does this define the sides? I'm guessing yes. Let's just make a new one. Let's make a new one. Let's do test scale. Let's make that 0.5. Let's make that 1. Okay? Perfect. Perfect. Amazing. It does. It does define the sides. It actually does. Okay, and also let's make... Did I make that public? Yes, I did. Perfect. So now I can just undo this. Actually. I didn't know that. I didn't know that it defined the sides. Okay.
Down, and it seems to be a fairly nice range of sizes we've got going. Of course, now that we're modifying the size, the bigger objects are spawning in with the sort of lower half of them protruding onto the screen. So let's fix that by, instead of just adding 0.5, instead adding the spawn size divided.
Yeah, the way he does it is probably more computationally efficient. But I don't care.
By 2.
I don't care right now.
Now that should be very accurate. They should spawn completely off the screen. And now that should be very accurate. They should spawn completely off.
That makes sense. That makes sense. I don't even think I need to do this. Pretty sure that's redundant. Great. Yeah, it is completely redundant. Why did he ask me to make a cube? What are these? Wait, this? What is this? Is this a plane? No. No, it's not. No. No, it's a cube. Why didn't... Is it a cube? Is it really a cube? It is. It's a cube. It's a cube. Yep. It's a cube. Okay, so this needs to actually be 0. Cool.
Off the screen. Okay, so next we want to get the blocks spawning in at an angle, and as I mentioned, I'd like the blocks to fall.
Okay, I'm a little confused. Why is this a cube, but those aren't? I'm a little confused, just a little bit. Okay. You know what? That's good enough for now.
Fall
I don't
in
care.
the direction of their rotation so that they're a little bit harder to dodge. This of course means that we don't want to rotate them too much, otherwise they'll be sort of flying off at all sorts of crazy angles. Another thing to quickly note is that when we're rotating like this in 2D, this is a rotation around the Z-axis. Alright, so
Makes
with that in
sense.
mind, let's head over to the spawner script.
Okay, I think that's all the information I need. That's not the right way to spell that. Do I want to make this public? Um, isn't there an easier way to do this? Yeah, you know what? This is just for the public part. I guess that's fine. But this is not even. Yeah, I'll just. Yeah, yeah, I'll just do this. Stop. Then I'll just do this. Actually, this. And you know what? I'll have. I'll just do it in the order that I put it. So we got hazard rotation equals random dot range. Why is that even still there? You know, I guess that's fine. You know what, sure. Range, hazard rotation. Just do the same thing. Why not? Just do the same thing. Okay. Hazard, um, rotation, hazard rotation. What the heck? The heck? Not X. Hazard rotation. Range. Not Y. Whoopsie. I'm so gosh dang tired. Okay. For vector 3 dot, there has to be something, please. There has to be something that has just a Z. Please. Negative infinity. Okay. I'm gonna look like an idiot if he does. If he has vector3 dot like some bullcrap where it's just the z value. But I'll just make this anyway. I'll just make this just z. And then this is 0, 0, 1. Cool. Just z. Amazing. Bam. Yep. Just see times hazard rotation. Cool. Okay. So now I do 90. Right, negative 90. 90. Actually, you know what? No, 45. And let's see, is this... Yeah, that's fine. That's fine. Completely fine. Ooh, maybe 45 is too much. 45 is too much, actually. Another thing here. Let me just do this. Already have it open. I don't know what I'm doing. Let me just look up and see if this is correct. Or operator C sharp. Okay, C sharp. Thank you. Oh, what? Okay, no. Never mind. Lol. Thought someone else typed in my chat. Like that would ever happen. Okay, now I have to do... You know what? I'll just do this. Despawn range Y. Despawn range... Positive... X. And then copy this. Just copy that whole thing. And then transform... Okay, I'm so lazy, bro. I'm so lazy. Just do that. Just do that. And then just do it again. And then that's greater than... And then this is another thing there. And then... Now we do another float, which is camera width. Camera half width. cool. And then we just do camera half width equals camera dot main dot aspect times camera dot main dot orthographic size. Is that correct? Also, this is supposed to be 2. And then let me actually think this through. Times negative 1.5. No. No. Alright, that's fine. And then, is this correct? Is this correct? I use a little different terminology, but yes, that's correct. Okay. And then we do despawn. Sorry, whoops. See, this is actually negative x. Despawn range, and I love how I have to retype the whole thing. Positive, let's do positive first. Equals camera half width times 2 half. And then despawn negative equals camera half width times negative 2. Okay, then we just do this. Despawn range negative x, and then despawn range, okay, which I'm just gonna do this here, because it still works. And then despawn range positive x. Amazing. That probably was an absolute waste of time, because if I have the angle small enough, they're probably not even going to they're probably not even going to go that far out. Okay. So now we do 20, 30, 30. Why not? I wish there's a way that was like a way that I could do plus or minus of the same number. Oh yeah. I guess I could just do like negative x, positive x. But whatever. It doesn't matter. Okay, and this is also way too small. This is kind of way too big. Okay, and this is also too much still. 20, 20. Yeah, the way he did it was better, where it spawns it at the top. But I can change that easily, I think. So if I go here, then I go spawn range. I just change this to spawner position time, oh, sorry, plus. That's why he did it. That's why he put it inside. All right. I can do that. I can do that. That's fine. I can do that. So that is not correct. That should be fine. I think. Right? Yeah. Yeah, that's it. So now spawner position. And this actually doesn't make a single difference now. So we don't make the spawn position is not dependent on the spawner position anymore. So yeah, just gonna delete that. Don't need it. Okay. And now I'm just gonna set this, just gonna reset this here. Can I reset it? Did I have it on the wrong thing? I probably did. I probably did. Okay, now let's check. Yep. Yeah, that works. That works. Or does it? Does the rotation make it a little bit more? Yeah, I think the rotation does make it a little bit more, like, show a little bit on the screen. So I'm just gonna do... I'm just gonna do 1.5. Can I get it? Can I catch it? Wow, it's really fast. That's really fast. So I'm just gonna actually change this here to like 2 or something. So I can see very clearly if it's working correctly. Okay, I want the really big ones. Let me just... Like, it might work for the small ones. Okay, it works. It works. I think. Yeah, I think it works. I think it works. Alrighty, so we go over here, we do oh, hazard rotation is public. So let's see if that's good enough. So I want all of the blocks to be visible on the screen. Like I don't want the angle to be so crazy that there are only some that just kind of like skirt the edge. I guess that is semi-unavoidable. Alright, that's fine. That's fine.
And let's create a public
Bro, these notifications just keep going up. People just want to keep arguing with me on YouTube.
float for our spawn angle max. And then...
What?
Over here we can say float spawn angle is equal to random.range somewhere between negative spawn angle max and positive spawn angle max.
That makes sense. That makes sense. That makes that kind of makes more sense. I don't know what I'm doing. This can just be a float. And this can just be negative spawn rotation. Hazard rotation. Never negative hazard rotation range. Positive hazard rotation range. That makes more sense. I like had it in the brain, but I just wasn't really thinking about it. Okay. Ah, I see. No. Yeah. Okay. Cool. So sure, 20, 30, whatever.
Alright, so now that we have our spawn angle, we know that the rotation of the object should just be that angle on the z-axis. So to get a vector with spawn angle on the z-axis, we just multiply spawn angle by vector 3.forward. Now, we of course need to convert that to a
What? Please don't tell me, really? Am I dumb? Am I actually dumb? Ah! Okay, I am. The consensus is that I am dumb. Let me just try something. Okay. Forward 001, down. Okay, we have up, down, left, right, forward, backward. Okay. And then we have 1, and then we have -1, right? Is that correct? Zero. We don't have -1. There's no -1. Okay, it's just back, not backwards. Oh, okay. I guess you could do 1 times a negative times a negative, and it would be the same thing. All right, I'm dumb. I'm dumb. Okay, sure, boom.
quaternion if we want to pass it into the instantiate method. And we've seen how to do this before. We can say quaternion.Euler, which is a method which takes in a vector 3 and returns a quaternion. So into there we'll just pass vector 3.forward multiplied by the spawn angle. All right. So one very minor thing to just be aware of is we've done these calculations to make sure that the object spawns in perfectly above the screen. But of course, if we now add some random rotation, we're going to get a little corner jutting in.
Oh,
And it's relatively unimportant, but of course to
my
fix
brain,
this,
I
instead
can't.
of adding half the height on to the position.
It's too big brain for me. I can't even. I have never thought about
Just
that.
add the object's full height
I'm
on,
kidding. I'm
so that no
kidding.
matter the rotation, it won't ever jut into the screen. So if we just
Do you really
quickly
need the
pop back
full
in here,
rotation?
instead of adding spawn size over 2, we'll just add the full spawn size to the object's height.
Really?
Alright, so let's go ahead and play this. Of course, we first want to set the spawn angle max, so I'll set that to say 15, and let's give this a play. So they're now spawning in at random angles. Of course, they're currently not colliding, so I don't actually have to do anything. But if I pretend that I'm desperately trying to avoid these, then it's kind of fun.
Ah.
Of course, just to mention
True.
that if you didn't want the objects to follow their rotation, then if you recall the episode on movement, we can simply add to the translate method, comma, space, dot, world, and then it won't move it relative to its own rotation, but rather relative to the world, so it will still fall straight down no matter its rotation.
True.
Alright, but we do want it falling in at an angle, so we can change this to space.self, or just leave it out entirely. It's the same thing. Great, so that's everything for this episode. Once again, I'd like to leave you with a little challenge, which is to detect collisions between the falling blocks and the player, and to destroy the player object if the block touches the player. So, good luck with that, and until next episode, cheers. Hi everyone, at the end of the last
Okay, I will do that on the next stream, but I'm gonna get ready to play Tower Fantasy because it just came out. And I will come back. So thank you for watching. I'll be back soon. Yeah, let me actually just do this. What the heck? Oh my gosh. Wow, I didn't know you could do that. That's pretty cool. Ah, ah, ah. Okay, very fun. Very fun. One step closer to actually making a real game. But yeah, I'll be back. Goodbye.